Tons of waste are produced every day. Unfortunately, the vast majority of what we dispose of ends up at the disposal site. There are approximately 400 disposal sites in operation in the Czech Republic, with more having previously been closed. A huge amount of troublesome and hazardous waste has been stored underground. This, our heritage to future generations, has rightly been referred to as an ecological time bomb. Various fermentative and putrid processes are at work inside the mass of solid municipal waste disposed of at the disposal site, whilst viruses, bacteria and other noxious substances also proliferate there. In order to prevent these dangerous substances from penetrating the soil and thus threatening the ecosystem, disposal sites are separated by foil. But, due to the effect of time, ruptures occur in the foil and subsequently the harmful substances leak into the ground. Furthermore, it is very difficult to find a location for a disposal site given the fact that its foundation renders a great deal of farmland worthless. To continue down this road might mean that we would find ourselves literally squelching through waste in a few years' time. There is a tendency within the EU to reduce waste storage in favour of using waste combustion to our own benefit. All EU member states deal with caring for the environment together, given that the environment crosses all borders. Waste incineration plants do not rule out recycling due to the fact that a great deal of combustible residue will be left behind even after recyclable materials have been sorted. So a modern waste incineration plant disposes of waste, whilst the energy capacity of such disposal can also be used to produce heat and electricity. The question is how? This you will find out in the next few minutes as we introduce you to the operation of the Termizo Joint Stock Company Municipal Waste Incineration Plant in Liberec. The incineration plant is a facility for the energy exploitation of waste. Primarily solid municipal waste which would normally end up at disposal sites is thermally utilised here. The annual capacity of the Termizo facility is 96,000 tonnes, which corresponds to half the waste produced in the Liberec region. Capacity is therefore easily fulfilled. The annual heat supply to the central distribution network amounts to 600,000 gigajoules. The facility also supplies 6,000 megawatt hours of electric energy into the distribution network per year. The Liberec Termizo incineration plant was put into operation in 1999 and has been working smoothly ever since. Operation at the plant is ensured by 4 highly trained professionals that work in continuous shifts. Most of the technological units here are fully automatic. The operators observe and monitor the functioning of individual parts of the incineration plant. The system through which the incineration plant literally changes waste into electricity and heat is illustrated on this chart. Waste is first stored in a bunker, from where it is transferred to the boiler. Here the process of controlled combustion takes place. The steam produced is then fed into the heating plant and subsequently passes through the centralised heat supply network to individual customers in Liberec. In the meantime, the steam is put to further use inside a turbine, where it drives a generator which produces electricity for company use. The steam then passes to the energy distribution network. This is how the Termizo incineration plant works, but now let us take a closer look at the technology involved. Solid municipal waste is transported into the bunker, which is accessible through 5 hydraulic-driven gates. The waste is mixed by a crane and so continually prepared for perfect combustion. Bulk waste is ground using hydraulic shears when necessary. After preparation, the crane operator loads the waste into the boiler hopper. As we have already mentioned, the facility is capable of processing 96,000 tonnes of waste a year, which means that 12 tonnes of it passes through the hopper every hour. The waste travels from the hopper to the hydraulic feeder, where it is further pushed onto a grate. The process of waste combustion takes place on this movable grate. Combustion air is then supplied for burning. The air is driven underneath the grate from the waste bunker via a fan and heated by a steam heater. This causes slight negative pressure inside the bunker, which reduces the emissions of dust and odour into the immediate vicinity. So-called secondary air is also supplied for burning. For this purpose, the facility uses recirculated combustion products, which are led from the boiler and blown into the combustion chamber by a fan. The amount of combustion product emitted through the chimney into the atmosphere is thus reduced, and the combustion process is executed in an ideal way. The waste is ignited using natural gas, and the combustion process is fully automatic. A control system monitors individual combustion parameters and continuously assesses possible deviations from the required state. Thanks to all this, ideal combustion and high quality incombustible clinker and ash residue are ensured. The maximum content of carbon in burnt clinker is 1.5%. This value is an indicator of high quality combustion. The combustion temperature on the grate varies from 900 to 1200 degrees Celsius depending on the capacity. The temperature in the burnout zone behind the combustion chamber, where combustion products stay for around 2 seconds, is between 850 and 1100 degrees Celsius. The energy released during waste combustion is taken from combustion particles in the form of heat and passed on for the production of water steam. The nominal output of the steam in the boiler is 35 tonnes per hour. The steam temperature is 400 degrees and the pressure 400 bars. The steam is first fed into a steam back pressure turbine with nominal output of 2.5 megawatts. The steam parameters are reduced here to a temperature of 230 degrees and a pressure of 10 bars thanks to the reduction in the turbine. 6,000 megawatt hours of electric energy are thus transferred into the electric distribution network. The steam from the turbine is fed into the central heat supply system in Liberec. The amount of effective heat supply is approximately 600,000 gigajoules per year. The process of the combined production of heat and electricity described above is called cogeneration. The efficiency of using the steam produced is around 80%, which proves the high energy efficiency of the process. Half the amount of the electricity produced is for the facility's own use. In other words, for ensuring the operation of the incineration plant. The rest is supplied to the energy network. In addition to high energy efficiency, emphasis is also placed on ecology at the Liberec incineration plant. The resulting combustion products, as well as the water used, ash and clinker, are all cleaned. Therefore, the heat and electricity produced at the incineration plant are generally amongst the cleanest sources of energy. We should first introduce the process of combustion product cleaning. Very strict emission limits are laid down for waste combustion. 4 stages of combustion product cleaning have been installed at the plant to meet these limits. These are the reduction of nitrogen oxides, the capture of ash, the capture of dioxins, and the wet cleaning of combustion product. The reduction of nitrogen oxides in combustion products takes place in the combustion chamber itself, where a 25% solution of ammonia water is supplied. So-called selective non-catalytic reduction subsequently takes place here. The ash contained in combustion products is captured by an electric separator. From discharge hoppers at the bottom of the separator, the ash is transported into the ash silo for further treatment. The residual part of the ash is then captured by a catalytic cloth filter, whose principal function is the decomposition of dioxins. Dioxins are disposed of via a special filter. The filter degrades dioxins into elementary components, i.e. water, carbon dioxide, and hydrogen chloride, by means of catalytic oxidation. Oxidation occurs in the layer of the cloth filter with a filtration area of 1,800 meters squared. The oxides remaining from combustion products are cleaned using a wet process. A scrubber for combustion products is used for this purpose and works in 3 stages. The first stage is a cooler or quench. This cools the hot combustion products to a temperature of approximately 65 degrees Celsius by injecting wash water. Smoke gases are saturated with water, which absorbs the major part of gaseous acids such as hydrogen chloride and hydrogen fluoride. The quench also condenses gaseous metal oxides, for example mercury. Coarse gaseous impurities enter service water during the process. Sulfur dioxide and sulfur trioxide are absorbed in the second stage of the scrubber. Here, the combustion products come into contact with softened water, into which caustic soda is added in a controlled manner. The combustion products head upwards and thus pass through the scrubber lining against the flow of the wash water. As a result, the exchange of substances takes place and sulfur oxides are removed from the combustion products while the value of pH in the wash water is maintained at 6. The third stage of the combustion product scrubber is a ring jet. This ensures the separation of dust and aerosols, i.e. the smallest particles. After leaving the third stage of the wet cleaning process, combustion products move to the chimney. The temperature of the combustion products is approximately 65 degrees Celsius upon leaving the scrubber. The cleaned combustion products pass through the service chimney into the atmosphere. The measurement of combustion products takes place continuously at the very end of the chimney. In the event of scrubber failure or a power cut, the combustion products are automatically redirected into a so-called emergency chimney, which is permanently closed by automatically controlled dampers. The combustion process stops simultaneously, and for the necessary period of time, only the combustion products from the waste burnout in the combustion chamber are released into the atmosphere. The combustion products are thus safely emitted into the atmosphere even in the case of emergency. Ash and slag are also generated by the waste combustion process in addition to combustion products. Soluble salts and extractable heavy metals are removed from crude ash to ensure that it does not exhibit any dangerous features. This is all achieved using acid water, which comes from the scrubber, particularly its first stage, the quench. The ash, which is stored in the silo after having been removed from the combustion products, is fed into a trio of extraction tanks. Here it is leached in acid water with pH 3.5 and a temperature of 65 degrees. The process of dehydration subsequently takes place on a vacuum filtration belt. Ash that is washed in such a manner moves to the slag bunker, where it is mixed with slag. This does not show any dangerous characteristics either. The material created is used in the building industry, for example for landscape restoration. The characteristics of the product are guaranteed thanks to production that is in line with quality certification. In order for operations at the plant to be genuinely environmentally friendly, it only remains to clean the water that is used for both the wet cleaning of combustion products in the scrubber and for the leaching of ash. Acid water passes to the water treatment plant, which consists of three parts. Chemical substances such as whitewash, hydrochloric acid and others are gradually added to the water. Heavy metals are released at a pH of 9.5, and these metals then settle into a fine sludge in the form of flakes. The sludge settles in the sedimentation tank, from where only clear water flows for final inspection. This is the final stop before the water is discharged into the sewer system. The sludge from the sedimentation tank is washed and dehydrated in a candle filter until solid waste, a so-called filter cake, is created. This is collected in special containers and taken to be solidified, after which it is disposed of at the hazardous waste disposal site. Apart from the production of building material from slag and ash, so-called sproke, a large amount of iron leaves the plant after being separated from clinker. Up to 75% of the iron contained in slag is captured every year thanks to an iron separation facility. This way, up to 4 tons of iron can be obtained from 100 tons of crude ash materials. Another ecological benefit is the fact that the energy utilisation of waste saves primary raw materials. In fact, the production of heat at the incineration plant reduces the production of other energy resources, and in the case of the Liberex plant, the 100% output means that 17 to 20,000 tonnes of heavy crude oil are saved per year. This is beneficial both for the environment and for people. The operation of the Liberex incineration plant is complex indeed, and we can only hope that we have managed to explain its functioning as clearly as possible. Let us not destroy the environment we live in. Let us try to use seemingly useless waste to our own benefit. Our children will undoubtedly appreciate it in the future.